Let's add a new dimension to our programs. Until now, we have been drawing everything in 2D, 2 dimensions. That was, we were using X and Y to locate any elements on the screen. Maybe we draw points or lines or circles, and each time we were calculating how far are they from the left border and from the top border of the screen. Well, it turns out that many drawing functions have a third parameter, and that's the value c. We can see that on the reference here. If we go to point, for example, we see that you can use point in 2 ways. You can use x and y, or x, y, and z. And what does this third parameter mean? To understand this third parameter, you should imagine that our screen is not flat, but we have a cube. And then using this third parameter, we can define how far into or out of this cube our point is, or our line. So using this third value, we can define if something is outside of the screen or if it's deep into the screen. So let's see this in action. And we're going to start by using a function called box. That's a 3D primitive. And box is really easy because we can call just using one parameter, size. You can also call it with 3 parameters if you want to define the width, height, and depth of a box. But if you just send one parameter, then processing will be assuming all 3 are equal. So let's make here just the very short program. Let's make box 50 and semicolon at the end, and what happens? It says box is not available with this renderer. What does that mean? Well, the size function is not only used for setting the size, but actually here there is a third parameter we can use, and this is the renderer we are using. Let's see again in the documentation what there is about size. I'm gonna search here size, and here it says the third one is mode, and we can use either P2D, P3D, and then 2 others. But let's choose just this P3D, that's like processing 3D. So here we type after the width of the screen and the height of the screen, I'm gonna type another parameter, P3D, and I'm gonna run the program. So this is not very spectacular for now. This must be our cube up there. How could we bring it more to the center of the screen? Well, the box function doesn't have parameters like the point function. When we draw a point, we can choose here x and y. Where do we want this? But with the box function, we don't have this option. So what we have to do is use translate. And I'm gonna translate, so I'm gonna push this box 100 pixels to the right and 100 pixels down. And with the translate function, I'm moving the axis. So let's see the result. So that looks much better. That looks like a cube now. And it's a very short program. That was easy. Instead of having it fixed at 100 to 100, let's make it move to wherever the mouse is. Mouse X and mouse Y. But this is not gonna work now because, well, at the beginning the mouse is just assumed to be in the corner. We have to make this into an animation. So let's add here a void setup. And there we will have our size function, and then a void draw. And that's it. Now it should work. Okay, it's working, but we are not erasing the screen. So let's type here background and 80 to make a dark background. Now run the program. And there it is. Now we have a 3D cube following the mouse. Translate is actually one of those functions that can have 3 parameters. And if we check on the reference, I'm gonna see here translate. And see, it has also 2 modes. You can use 2 parameters, x and y, or 3, x, y, and z. So let's try here adding a third parameter, and I'm just gonna add here 100 to see what happens. It doesn't look very different. What if we type 200? Well, I think it's getting larger. What if we type 260? So it's getting closer and closer to us. And if I type negative numbers, if I type minus 260, then it's very far away. So now you can see that with this number here, we can define how close or far away the object is from us, or actually the axis. What we are doing with the translate function is defining where is the origin. So we could animate this to see just what happens. We could type here some randomness, random minus 200 and 200, but it probably will not look very nice. It's just a jumping box that goes back and forth. If we use noise, it would look much better. So we should use noise of some variable, like noise of a. So I'm gonna declare this variable at the top, float a is 0. And each time we call draw, we increase a equals a plus 0.01. But now a just goes from 0 to 1. We would not notice this. So that's why we should map this noise, that is a number between 0 and 1, into something more interesting, like minus 200 and 200. So let's see now what happens. If I leave the mouse here, and now the box is moving slowly to the back and to the front. Maybe I should increase these numbers to see more the effect. Okay, there we have our moving box. Let's add one more interesting effect here. We have discovered how to draw a box, which is a 3D cube. We have to use this renderer here, P3D, and we know how to translate. That means how we can move our box anywhere on the screen. Let's see how we can rotate. And we have used rotate before, but now we're going to see that there are actually 3 rotate functions more, called rotate X, rotate Y, and rotate Z. So I'm going to try just to use one of them, rotate Z, and a variable here R, which I'm going to be increasing. So I'm going to define here a new variable, float R is 0, and I'm going to say here R equals R plus 0.1. Let's see now what's happening. And now we have a spinning box. This box moves to wherever my mouse is, and it also randomly goes to the back and forth. If I want to change the speed of rotation, then I should change this value here. If I type 0.02, now it's gonna rotate much slower. So I'm gonna leave it there for now, and you're gonna have time now to practice. You can draw things on 3D. You can use translate to move them around the space, and you can use rotate X, rotate Y, and rotate Z to rotate these objects in different directions. So have fun spinning things around in space.